Hi everyone, welcome to Geek Math. We are going to tackle the last 5 problems of 1993 AMC8. Okay, so let's go to question number 21. If the length of a rectangle is increased by 20% and its width is increased by 50%, then the area of the rectangle is increased by. So it's simple, right? So say suppose the length and breadth are x and y. Okay, erase this, go back. Okay, so length is x and y. So the area will be xy. This is 1, right? Then the area is increased by, so x and y being the length, area will be equal to xy. Now here the length is increased by, so x becomes 20%, 1.2x, right? And y becomes 1.5y, correct? So this is going to become 1.2x into 1.5 into 1.5y, right? So that becomes 150, 165, 180, right? So it's multiplications. It's going to become 0, 180, 1.0xy. So from this it becomes 1.8, 1 to 1.8, which is an increase of 80%, right? So this is your answer. Going to the next question. Pat piano has plenty of zeros, ones, threes, fours, fives, six, sevens, eights, and nines, but he has only 22 twos. How far can he number the pages of his scrapbook with these digits? Okay, so how far can he number the pages? So the last number, this basically means the last number he can write. This is the meaning, right? This is what it means. So let's check now. So in single digits, how many twos? Number of twos. Okay, in single digits, that's 1. Okay, in double digits. Okay, so we have, if we count, right? So if we count from 12, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Then we have 32, 42, 52, 62, 72, 82, 92. And then in 22, we have 2 twos. So I'm going to count one more. So it's 19. Okay, so double digit 19 twos. So totally how many we have? 19 plus 1, 20. Right, so this makes 22s. So till with 22s, he can write till the till all the 2-digit numbers. Now in the 3-digit numbers, he has how many more twos? He has 2 more, right? So he can write in 3 digits. He can write 102 and 112. Okay, but 112 is not your last number, right? Without twos he can write many more numbers, isn't it? So 2 is over, but he has all the other numbers, so he will keep on writing till he reaches the next 2, which is at 120. He won't be able to write 120, but he can write till 119. Got it? So it's a tricky one, so you should not answer as 112, you should answer as 119. That's your answer, D, 119. Going to the next. Question number 23. 5 runners P, Q, R, S, T have a race. P beats Q. Okay, so P beats Q. So I'm going to, okay, let's just say I'll put like this. P beats Q. So P is winning. I am putting an arrow on his side. Okay. Now P beats R. So P beats R. Okay. Then Q beats S. Okay. Q beats S. Okay. But P already beats Q. So P also beats S. Correct? Okay, P also beats S. Then T finishes after P. So P beats T. Okay, now look at this. And before Q. So T is before Q. So T is here and Q is here. Q has already bet S. So T will beat S also. Correct? And then who could not have finished third in the race? So we don't have to find out all the positions. We just have to find out who cannot be in the third position. Okay. So let's just check. Now that we have written this, let's proceed by placing them on the lines. Now if you see P, so this side is winning, this side is losing. Okay, so 1, 2, 3, 4. So 4 of them lose to P. So P will definitely be here. Okay, now Q we only have 2. We cannot tell where Q will be placed. Similarly, R also we cannot tell. Now let's take S. Now you see this S has lost 1, S has lost 2, S has lost 3. So if S has lost 3, where possibly can S be? So S can either be here or here. Got it? Because 3 he has lost to 3 people. So those 3 people will always be before S. So S can either be here or here. So the two things which cannot be in 3 is P and S, which is this C, P and S. Got it? Going to the next question. What numbers directly above 142 in this array of numbers? Okay, looks tricky, but let's just try to write more of this and then understand what best can we get. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Now just keep looking at these numbers here in the last line. What is the pattern you are seeing here? What are the numbers? These are all square numbers, right? See this? These are all square numbers. So going by these, we are going to have square numbers towards the end always, right? And what is the number directly above 142 is what we want. Okay, now if these are all square numbers, we're not getting any square numbers in the middle. All the square numbers are coming the end. So what is the nearest square number to 142? So it is going to be, if I keep going, so 144 will be a square number, correct? So 143, this will be, here will be 143, and here you will have 142, correct? So this will become 143, this will become 142. Now the line, the number above this, okay, will be two numbers before um, the previous square number. So what is the square number previous to 144? So in the previous line, right? So that will be uh, 121. Okay, and it will be 1 to the left of 121. So here it will be like this, 120. Got it? So this is how it will come. Sorry, like this. Okay, so 144, 142, and above 142 you will have 120. So here is your answer, C, 120. Going to the next question. Question number 25. A checkerboard consists of 1 inch squares. We don't know how many squares, we can assume, but a square card 1.5 inches on a side is placed on the board so that it covers part or all of the squares of each of the n all part or all of the area of each of the n squares. The maximum possible value of n is. So with a 1.5-inch square, how many smaller squares can we cover? That's the question. So let me draw this. Okay. I'm just going to make 4 boxes here. I'm going to say each of this is 1 inch by 1 inch. So 1 inch, 1 inch, 1 inch. So these are all 1 inch cubes, right? So I have 16 such cubes. I'm just assuming there can be more, right? So this can go this side also, this can go this side, or it can be more. What are we trying to do? We are going to take a 1.5 inch side ka square card and place it on the board, and it will cover up some squares. So for example, if I take this, okay, 1.5 inch, so this is 1 inch, right? So 1.5 inch is going to be here, correct? So what I'm going to do, let me take a different color only. This color is a little, yeah, okay. So say this part, okay, 1.5 will come like this. So if I'm going to cover it like this, now see how many boxes it is covering, either partially or fully. 1 2 3 4, right? So in this case n becomes 4. If it's like this covered, n becomes 4, but we have to maximize the value of n. Is there any other way that we can place this smaller square, this blue square, so that it covers more of this part? So can I, how can I place? So this I have placed it straight, right? I can tilt it and place. So if I tilt it and place, will I cover more squares? And if I cover, how many squares will I cover? That is what I need to check. Okay. So first what I'll do, if I tilt, obviously it will come in the form of a diamond. Okay. So I have to find the measure of this diagonal. Okay, so how will I do that? See, this diagonal I need to measure just to see if I can keep it in terms of a diamond, and it will cover more area. Got it? So for this one, what I'll do, I will say this is 1.5, this is 1.5, this is the hypotenuse, right? So the diagonal will be 1.5 square plus 1.5 square. Okay, square root of, this is the hypotenuse, which is the diagonal. So this is nothing but 2.25 plus 2.25. So we add, we'll get 4.5. So this is going to be the square root of 4.5. Now the square root of 4.5, let us see whether this is larger than the side. So this is definitely greater than 2, right? So not equal to, it's greater than 2. So it is, this diagonal is greater than the side of two squares, two smaller squares. So this is one, this is one, right? The red square I'm talking about. So two red squares, side is 2, but here I have something which is greater than 2. So then I can draw like this, right? So let's draw one more here so that it's clear. Okay, now see this is 2. Okay, but now we have the diagonal which is greater than 2. Okay, so I'm going to place the square like this. See this, like this. Okay, why? Because it is greater than this, right? This diagonal is greater than this, so I can place it like this. Now you tell me how many squares is this covering, right? So it's covering, let's put 1 2 3 4 5 6 7 8 9 10 11 12. See this, these four sides corners are not covered, but it covers these squares. That's because this diagonal is bigger than two squares here, so we can tilt it and keep it like this. So answer will be 12 or more. Answer option E. Clear? Thank you.